Good evening, everyone. How are you? I hope you people are doing well. I'm Devendra Singh Negi and I welcome all of you to this Jham session on fluid mechanics compressible flow. So my friends, let me introduce myself. My name is Devendra Singh Negi. I'm the mechanical head on Unacademy brands, Gate All India Rank 1 2019-20 Engineering Sciences paper. I completed my master's from IIT-BOMBAY. I was the topper of my batch and I'm teaching for Gate and ESC since 8 years. Until now, I have mentored more than 50,000 students in offline, online or through seminar mode. So those who are coming first time to this YouTube channel, kindly subscribe this YouTube channel because it is going to be your one-stop solution for all the competitive exam preparation. And my friends, today we are going to discuss this beautiful concept of pressure distribution in a converging nozzle. So are you ready? Bolo re baba, bolo re baba, bolo re baba, bolo re baba. Are you ready? Ready हैं आप लोग? बोलिए बोलिए बोलिए. Very good, very good, very good. Excellent, excellent. Hit the like button re baba, hit the like button re baba. Hit the like button. Very good, very good, very good. So my friend, these are the batches which we are running on Unacademy Plus: beginners batch, explore batch, target gate 2021 batch for mechanical, target gate 2021 batch for engineering sciences paper. So those who are in third year, immediately join beta because I am starting thermodynamics very soon. Those who are willing to join Unacademy Plus and are in second year, they can join because I will be starting thermodynamics. Now my friend, this is the crash course which we started from 21st of September. This is basically the all-star batch where all the star educators of Unacademy mechanical team are teaching. I will be taking the subjects in this batch: Marut sir, Madhut Raj sir, Gaurav Babu sir, Aprup sir, Rajiv sir, Jitendra Singh Gill sir will be taking the classes in this particular batch. So my friends, the most awaited subject on Unacademy Plus, basic thermodynamics, I am starting from 26th of October. From 26th of October, I will be starting this subject. So immediately join Unacademy Plus if you are preparing for engineering sciences paper. Already fluid mechanics is going on and you can join this subject from 26th of October. Everything will be live. Everything will be covered for engineering sciences paper, for mechanical paper, right? Chaliye. I hope you are aware of this, right? Mechanical plus XC matlab what? Or those who want to join Unacademy Plus, the only code is for you people, my friend. Negi 10, Negi 10, Negi 10, and this is the series is going on, my friend. Tomorrow, Approve sir will be taking the MSQ, MCQ, NAT series on engineering mechanics. Chaliye. Now this is 100 days free crash course for Gate 2021 aspirants. We are starting 600 hours live classes. 4 subjects every day. Complete syllabus will be covered, my friends. And when are we going to start this particular batch? We'll be starting this crash course from 1st of October and 8 days to go. Oh my god, oh my god, oh my god. Chalo, chalo. Shall we start? Shall we start? Bolo re baba, bolo re baba. Shall we start? Start karenge? Bolo re baba. Kindly share the link with your friends. Oh my god, oh my god, oh my god. Okay. Like karo re baba, like karo re baba. Kindly share the link in various groups, my friends. Strength is very less. Strength is very less. Kindly share the link with your friends so that we will be moving forward. My friends, in the last class, today will be the last class of compressible flow, beta. Today will be the last class of compressible flow. If strength is less, today I will finish this. Today I will complete this subject, this chapter. If strength is less, I will finish it off. I will not discuss in detail. I will give only the basic concepts. That's it. Chalo. Now listen carefully. In the last class, we have discussed what, beta? Mass flow rate per unit area. Mass flow rate per unit cross-sectional area is maximum at Mach number is equal to 1. When the Mach number is 1, mass flow rate per unit area, per unit cross-sectional area will be maximum at Mach number 1. Yes or no? Yes or no? Bolo re baba, bolo re baba. Sai Teja, this is not for the civil students, beta. चलो. यहाँ तक clear है बेटा? यहाँ तक clear है? This is what we have discussed in the last class. Do you remember, my friends? Do you remember? This is what we have discussed in the last class. आपको याद है? This is what we have discussed in the last class. Now, what is the meaning of mass flow rate per unit area is maximum? That means I am having maximum mass flow rate. I am having minimum cross-sectional area. at Mach number is equal to 1. Correct? Now what is the meaning of this, beta? What is the meaning of this? What is the meaning of this? Try to understand. That means I will be having the maximum mass flow rate when at minimum cross section area, Mach number is 1. I will be getting the maximum mass flow rate at minimum cross section area when the Mach number is 1. Now what is the meaning of minimum cross section area? ये आपको समझना पड़ेगा बेटा. What is the, listen carefully. According to this formula, m dot by a maximum at Mach number equal to 1, the meaning is mass flow rate maximum. Arey, when m dot by a will be maximum, when m dot is maximum, a is minimum. So m dot maximum by a minimum at Mach number equal to 1. That means I will be having the maximum mass flow rate when I'm having Mach number 1, at minimum area of the cross section. Now what is the meaning of minimum area of the cross section, beta? Let us try to understand. What a beautiful concept, my friends. What a beautiful concept. Look at here. Observe carefully. Kindly share the link with your friends, my friends. Kindly share the link with your friends. अपने दोस्तों के साथ शेयर कर दीजिए ये लिंक. Oh my God, yeah, what a beauty. बेटा ध्यान से देखेंगे अब. Oh my God, let us suppose this is the inlet plane. To a converging duct. This is the outlet plane of a converging duct. I am writing exit plane. E लिख दिया. Now let us suppose we are having flow through this converging duct. And we are having isentropic flow. Let us suppose we are having isentropic flow. Let us suppose we are having isentropic flow. Now listen carefully, my friends. For this converging duct, बिल्कुल ध्यान से देखेंगे बेटा. For this converging duct, are you able to understand? Where I am having the minimum cross section area. अरे ये तो कोई अंधा भी बता देगा रे बाबा. Even a blind person can say here at the outlet, at the exit plane of the nozzle, at the exit plane of the converging duct, I will be having the minimum cross section area. चलो बेटा एक चीज और डिस्कस करता हूं, ध्यान से देखना. Let us suppose I am having converging diverging duct. Oh my God. Let us suppose I am having converging diverging duct. बिल्कुल ध्यान से देखेंगे बेटा. Please observe carefully. Oh my God. Look at here. Let us suppose we are having the converging diverging duct. Now look at here, my friends. You are aware of this. Look at here. The beautiful concept, my friends. This is your inlet plane and this is your outlet plane, exit plane. Look at here. This is the inlet plane of the converging diverging duct. And now look at here, my friends. Observe carefully. This is your exit plane. Of the converging diverging duct. Any intelligent student of the class, for this converging diverging duct, where the minimum cross section area will occur? Anyone in the class? Where the minimum cross section area will occur? Type in chat box, re baba. Type करो रे baba. Where the minimum cross section area will occur for this converging diverging duct? Type in chat box. Very good. Excellent. Beautiful. Yes. Very good. Type करो रे baba. Quickly. I want everyone to type in chat box. Oh my God. Look at here. This. Excellent. That's what. ध्यान से देखेंगे बेटा. Yes, this is throat. Yes, excellent. At throat, excellent, beautiful students. At throat, I will be having the minimum cross section area. Now listen carefully, my friends. What formula is saying? Formula is saying I will be having the maximum mass flow rate through this converging duct or through this converging diverging duct or through this converging diverging duct. Excellent beta, excellent, beautiful, very good. Converging diverging duct. If the Mach number is 1, if Mach number is 1 at the minimum cross section area, that means if I am having Mach number equal to 1 over here for the converging duct, or if I am having Mach number here for the throat, I will be getting the maximum, whatever the mass flow rate will be taking place through these ducts, that will be maximum. I hope everyone is clear. Now I hope everyone is clear where we want Mach number to be 1. We want Mach number to be 1 at the minimum cross section area. Bolo re baba, bolo re baba. Good evening, good evening, good evening. Yes. Bolo re baba. Are you clear till here? Bolo re baba. Are you clear till here? Yes, Komal, very good. Nikhil, Suresh, Raju, very good beta. Nitesh, Naveen, Shivam, excellent. Namaste. Vikas, bolo re baba. Are you clear till here? Are you clear till here? आगे चलूंगा बेटा. अगर आपको यहां तक क्लियर है तो आगे चलूंगा. रिमेंबर आई हैव टोल्ड यू क्लियरली इन द कन्वर्जिंग पार्ट ऑफ द डक्ट यू कैन नेवर हैव मैक नंबर ग्रेटर देन 1. The maximum possible value of Mach number can be 1. So if at the exit plane of the converging duct I am having Mach number 1, and if at throat of the converging diverging duct I am having Mach number 1, then 100% whatever the mass flow rate I am having through these ducts, that will be what? Bolo re baba, maximum, and 100% you are able to understand. If I'm having subsonic flow at the inlet, or if the flow is coming from large reservoir, then this converging duct will be acting as nozzle, and this diverging duct will be acting as what? बोलो रे बाबा. देखो मैंने आपको ऑलरेडी बताया हुआ है यहाँ पर क्या होने वाला है. This converging duct will be acting as what? Nozzle. This I have told you. If I'm having the subsonic flow here at the inlet, maybe this flow is coming from the some reservoir, or I'm having some subsonic flow, then this will be behaving as nozzle. Similarly here, if I'm having subsonic flow, at the nozzle, then 100% this converging duct will be behaving as a nozzle. Any intelligent student of the class, this diverging duct will be behaving as what? If at the throat, मैंने बताया हुआ बेटा, if at the throat I got Mach number 1, then this diverging duct will also behave as what? Nozzle, because here also velocity will keep on increasing. Velocity will नहीं बेटा, ध्यान से देखो, ये diverging duct, इसीलिए मैंने पूछा आपको, don't be confused बेटा, don't be confused. If I am having Mach number 1 here, अगर एक बार यहाँ थ्रोट पे Mach number 1 हो गया, then the velocity will keep on increasing, and at the outlet I will be having supersonic flow. At the outlet I will be having supersonic flow. मैंने बताया हुआ है बेटा, एक बार देखना ध्यान से. Supersonic flow. Yes or no? I hope you are able to recollect बेटा. 100% velocity will keep on increasing, and this diverging duct will be behaving as what? Nozzle. Preetam, welcome. Chalo beta, now the most important thing. Sir, how? देखो बेटा, ये आज का सबसे इंटरेस्टिंग टॉपिक है, एंड आई विल बी डिस्कसिंग दिस टॉपिक ओनली. आज मैं पूरे 1 घंटे में यही टॉपिक डिस्कस करने वाला हूं. बहुत ही बेहतरीन टॉपिक है बेटा, बिल्कुल ध्यान से सुनेंगे. प्रेशर डिस्ट्रीब्यूशन इन अ कन्वर्जिंग नोजल. हाउ द प्रेशर विल बी वेरिंग. एक बार ध्यान से देखना बेटा, आपको पूरा समझाता हूं, बिल्कुल ध्यान से देखते हुए चलेंगे. लेट अस सपोज आई एम हैविंग वन लार्ज रिजर्वायर बेटा. ध्यान से देखेंगे बेटा. Let us suppose I am having a large reservoir. Let me say this is one large reservoir which I am having. Now let us suppose with this large reservoir we have connected some nozzle. कोई nozzle connect किया हुआ है. चलिए, ये nozzle connect किया हुआ है. With this large reservoir we have connected the nozzle. अब देखो, let me say this nozzle is discharging to some tank, किसी टैंक पर डिस्चार्ज कर रहा है. ये कोई टैंक है, इस टैंक पर डिस्चार्ज कर रहा है. बेटा ध्यान से देखना, बहुत मजा आने वाला है. यू आर गोइंग टू एंजॉय टुडेज क्लास, सो प्लीज ऑब्जर्व केयरफुली. नाउ दिस टैंक इज कनेक्टेड, दिस टैंक इज कनेक्टेड टू सम पाइप. ये जो टैंक है ये किसी पाइप से कनेक्टेड है. Now listen carefully my friends, and let me say here I am having some valve which can regulate the flow. यहां पर मेरे पास कोई valve लगा हुआ है, and here it is discharging to the environment. यहां पर आपका environment है, here it is discharging to environment. Now listen carefully. Now listen carefully. Let me say this nozzle is completely insulated. बेटा ध्यान से देखेंगे. Let me say this converging duct is completely insulated. Now listen. नहीं बेटा, विकास थ्रोट पर नहीं. देखो, अरे आई एम हैविंग द स्टडी फ्लो ना, आई एम हैविंग द स्टडी फ्लो. डोंट थिंक मास फ्लो रेट विल बी मैक्सिमम एट नोजल. अरे ये तो हर जगह, when whatever the mass flow rate I am having at the inlet, same mass flow rate I will be having at the outlet also ना. बेटा don't be confused. If I am having the maximum mass flow rate, same maximum mass flow rate will occur throughout every cross section. हर जगह वही m dot max होगा, हर जगह वही m dot max होगा बेटा. Don't be confused. Okay. Now listen carefully बेटा, ध्यान से सुनना. Let me say this is reservoir. This is large reservoir. बेटा ध्यान से सुनेंगे, बहुत ही बेहतरीन चीज बताने वाला हूं आज. Today you are going to enjoy like anything. Let us suppose I am having one large reservoir. Now let us suppose the pressure here is P naught. Of course stagnation pressure reservoir में हम मान सकते हैं ना, static condition है, कुछ stagnation condition है. P naught, T naught, and density is rho naught. Now look at here. From here the fluid flow is entering the nozzle, and I am having isentropic flow. Now let me say the pressure at the inlet of nozzle, of course it will be approximately P naught only. P naught आप बोल सकते हैं. Now let me say the pressure at the exit plane of the nozzle is a PE. Let me say the pressure inside this tank, this is some tank kind of thing. It is having some pressure, let me say back pressure PV, and this is the valve which can control the flow. This is the valve which can control the flow. अब देखो बेटा कैसे वेलोसिटी मेंटेन करते हैं. मैंने बोला ना, देखो अगर सपोज यू आर हैविंग लेसर वैल्यूज ऑफ मैक नंबर and you keep on increasing the velocity, what will happen? Mach number will keep on increasing. Let us suppose we are increasing the velocity in such a way that Mach number at the outlet of this converging duct, at the exit plane of this converging duct becomes 1, then I will be having the maximum mass flow rate. अब ध्यान से देखना बेटा, ध्यान से देखना, आपको कुछ चीजें समझाऊंगा, बिल्कुल ध्यान से देखना बेटा. Let us suppose this valve is completely closed. मान लीजिए जो valve है, let us suppose this valve is completely closed. What is your observation? Do you think there will be any flow? बोलो बेटा. If the valve is completely closed, do you think there will be some flow? There will be any flow? ये मुझे confirm करो बेटा. I'm asking you. Please confirm me. Please confirm me. If the valve is completely closed, will I have any flow through the converging duct? ये जो converging duct है जो कि nozzle की तरह behave करेगा right now, because I will be having very less velocities at the inlet of nozzle, so 100% it will be I will be having subsonic flow at the inlet of the nozzle, or literally zero velocities, right? So I can assume this converging duct will be behaving as nozzle. तो मुझे एक चीज बताओ, what will be the flow? Flow will be zero. There will be no flow. There will be 100% zero velocity. बेटा आप ध्यान से देखना, बिल्कुल ध्यान से देखेंगे बेटा. Let me say This plane is representing the inlet plane of the nozzle. Let me say this plane is representing exit plane of the nozzle. Let us suppose this plane is representing inlet plane of the nozzle. Let me say this plane is representing exit plane of the nozzle. जो समझाऊंगा समझना बेटा ध्यान से, जो समझाऊंगा समझना बेटा ध्यान से. Now listen carefully. When I am having zero flow, when the valve is completely closed, when the valve is completely closed, are you able to understand beta? This PO, PE, pressure at the exit plane of the nozzle, and this PV, all will be equal. Don't you think all will be equal? 100%. confirm कर दो बेटा, confirm कर दो, confirm कर दीजिए. If there is no flow, this pressure P0, this pressure PE and this pressure PV, all will be equal. confirm कर दीजिए, confirm कर दीजिए, confirm कर दीजिए बेटा. Can I say? हाँ, यहाँ पे हर जगह फ्लूइड भरा हुआ है, हर जगह फ्लूइड भरा हुआ है. If valve is completely closed, can I say PO, PE and PV all will be equal? Confirm me, confirm me. Yes, of course, of course. अब ध्यान से देखना बेटा, बिल्कुल ध्यान से देखेंगे. Let me say here I am representing, बेटा ध्यान से देखेंगे. Let us suppose here I am representing pressure. Let me say here I am representing velocity. ध्यान से देखना बेटा. Let me say this line is representing zero velocity. Let me say this line is representing pressure P0, zero velocity. So I hope you are able to understand. When the valve is completely closed, when the valve is completely closed, there is no doubt, there is no doubt, PO, PE and PV will be all equal. So I can write PE is equal to PV, और क्लोज कंडीशन में है ना तो नॉट लिख देता हूं. P0 is equal to PV0 is equal to PO. एंड हेयर देखो वेलोसिटी V0 is equal to 0. अब ध्यान से देखना बेटा. हाँ, now let us suppose I am opening the valve a little bit. Let us suppose I am opening the valve a little bit. Now what will happen my friends? जैसे ही वाल्व थोड़ा सा खुलेगा क्या होगा? जैसे ही वाल्व थोड़ा सा ओपन होगा क्या होगा बेटा? 100% द फ्लो विल स्टार्ट. 100% द फ्लो विल स्टार्ट. कंफर्म कर दो. कैन आई से 100% द फ्लो विल स्टार्ट? यस, यस, 100%. When the valve is opened, this PV will decrease. This back pressure will decrease. Let us suppose the back pressure decreases to this value. Let us suppose the back pressure decreases to this value. तो क्या होने वाला है ध्यान से देखना बेटा. The fluid will start flowing at the inlet. At the inlet of the nozzle, pressure will be P0 only, but at the exit, pressure will become equal to this PV1. Let me say when the valve is opened a little bit, back pressure decreases to PV1. Back pressure decrease होएगा and of course it will be less than P0. It will be less than P0, and I hope you are able to understand now. The pressure will decrease something like this. Pressure will decrease something like this. ये confirm कर दो. Yes. Now the flow will start. Flow will start. So 100% velocity will increase. So let me say now I am having velocity is equal to V1. Of course V1 will be less than C, but there will be some velocity. There will be some velocity. ये confirm कर दो बेटा. ये confirm कर दो. यहाँ पर किसी को doubt है क्या? यहाँ पर किसी को doubt है क्या? ये मुझे confirm कर दीजिए. Of course PE1 will be equal to PV1, but it will be less than P0. In first diagram I am representing pressure. In second diagram I am representing velocity. As I am opening the valve, velocity will keep on increasing, keep on increasing, keep on increasing, and it will be less than sonic velocity, sonic speed. Here the pressure will keep on decreasing, and finally at the exit pressure will become equal to PV1, but it will be less than P0. Clear? Now let us suppose I am opening little more. अगर मैं थोड़ा सा ओपन करूं और थोड़ा सा और ओपन करूं तो क्या होगा? Now if I am opening little more, further the back pressure will decrease. अभी back pressure और decrease कर जाएगा. Now let me say the back pressure is PV2. Now let me say the back pressure is PV2. Of course it is less than P0, there is no doubt. Or you can say it is further less than PV1. अब क्या होगा बेटा, ध्यान से देखना. Of course pressure will further decrease, 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 and finally it will become equal to PV2 at the exit. And here also velocity will keep on increasing, keep on increasing, keep on increasing, and of course I will be having V2. I will be having V2. This V2 will be greater than V1 but less than C. ये कंफर्म करो बेटा, ये पार्ट क्लियर है? आर यू क्लियर विद दिस पार्ट? यस यस वरुण. येलो लाइन्स आर रिप्रेजेंटिंग एंट्रेंस, इसलिए मैंने येलो से रिप्रेजेंट किया बेटा. दिस इज एंट्रेंस, दिस इज एग्जिट. कंफर्म करो बेटा. आर यू क्लियर टिल हियर? आर यू क्लियर टिल हियर? कंफर्म कर दीजिए. आर यू क्लियर टिल हियर? प्लीज कंफर्म मी. नाउ लेट अस सपोज आई एम फर्दर ओपनिंग द valve in such a way that, अब ध्यान से सुनना बेटा, now the concept is coming. Now the concept is coming. Let us suppose I am further opening the valve in such a way that the velocity of the fluid flow becomes equal to the speed of sound at the exit of the converging duct. Means let us suppose I have further opened the valve, I have further decreased the back pressure, I have further decreased the back pressure. Now let me say back pressure is equal to PV3. Of course this PV3 is further less than PV2. Now what will happen? Let me say the velocity at the inlet is 0. It will keep on increasing, and finally let us suppose here the velocity becomes equal to speed of the sound. That means here the Mach number becomes equal to 1. Here the Mach number becomes equal to 1. Now what will happen? What will happen to the pressure? Please observe pressure को क्या होगा, ध्यान से देखना बेटा. Pressure will be P0 at the inlet, but it will keep on decreasing, and finally here pressure at the exit PE3 in this third case will be becoming equal to PV3, but it will be less than PV2. अब ध्यान से सुनना बेटा. Now the concept is coming. मैं और खोलता हूं. Let us suppose I am further opening the valve. Let us suppose I am further opening the valve. Now what is going to happen? अब क्या होने वाला है? Now look at here my friends. Look at here. This is your PV4. Now listen carefully. When the Mach number becomes 1, means if I have opened the valve in such a way that the velocity of the fluid flow at the exit of the convergent duct is becoming equal to the speed of the sound. That means Mach number becomes 1. I hope you are able to recollect the pressure at that instant is known as sonic pressure. Sonic pressure मैंने बताया था बेटा. When the Mach number is 1, the pressure will be known as what? Sonic pressure, or sometimes people are calling as critical pressure also. Now if I am further decreasing, that means if I am further decreasing the back pressure is now less than the critical pressure. What is going to happen? Try to understand what is going to happen, my friends. If you see here to the velocity thing, my God, you have increased the opening of the valve, that means you have decreased the back pressure further, which is less than P star, but there is no change, in velocity, I will be getting the same velocity at outlet. V4 will be equal to V3 will be equal to speed of sound. Mach number will remain 1 only, because you know Mach number cannot go beyond 1. आपको मैंने ऑलरेडी बताया हुआ है, मैक नंबर 1 से ज्यादा तो हो ही नहीं सकता. दैट मीन्स नाउ even if I'm opening the valve further, there is no meaning, velocity is not going to change. Let us see what will happen to the pressure. बेटा बहुत ही इंटरेस्टिंग कॉन्सेप्ट बता रहा हूं. Now what will happen to the pressure? Look at here, बेटा ध्यान से देखना. Pressure distribution will also remain same. It will follow the same path as that of earlier, where I was getting the sonic speed at the outlet of the converging duct, और यहां से then pressure will decrease, and this is known as 3D expansion waves. There will be some discontinuity. Listen carefully, जो बोल रहा हूं ध्यान से सुनो. PE4, that means when I'm opening further beyond the sonic speed, I have achieved at a certain opening, I have achieved the speed of sound, I am opening further. Then PE4, pressure at the exit plane of the converging duct will be equal to PE3 will be equal to PV3 or P star. It will not change. But as the flow is moving forward from the exit plane of the converging duct to the tank, there will be sudden discontinuity of the pressure. There will be sudden fall of the pressure, and there will be some formation of what? 3D expansion waves. Because finally it has to come to PV4. Finally, the fluid has to come to PV4, but remember, at the exit plane of the nozzle, it will be having the pressure of P star only. 3D expansion wave. बोलो बेटा यहां तक क्लियर है? I will tell you each and everything. नहीं शिवम, मैं तो अभी कन्वर्जिंग नोजल की बात कर रहा हूं. आई एम टॉकिंग अबाउट द कन्वर्जिंग डक्ट ओनली. यहां तक सबको क्लियर है क्या? आर यू क्लियर टिल हेयर? यहां तक कंफर्म कीजिए बेटा. आर यू क्लियर टिल हेयर? बोलो रे बाबा. सर व्हाट आर यू कीपिंग हेयर? बेटा हेयर आई एम कीपिंग, दिस इज रिप्रेजेंटिंग लेंथ ऑफ द नोजल, एक्स डायरेक्शन. कंफर्म करो बेटा, कंफर्म मी. नहीं बेटा, गेट के लिए प्रिपेयर कर रहे हो तो उतना काफी है. बोलो रे बाबा, आर यू क्लियर टिल हेयर? अच्छा, सबको समझ में आ गया. ओ माय गॉड, नो वन इज हैविंग द डाउट. बोलो रे बाबा, नो वन इज हैविंग द डाउट. आई होप एवरीवन इज क्लियर टिल हेयर. बोलो रे बाबा. एनीवन हैविंग एनी डाउट, फील फ्री टू आस्क. अब मुझे एक चीज बताना बेटा, इसका मतलब क्या हो गया? ध्यान से सुनो. I have given you one feel. Try to understand. We cannot have Mach number more than 1 at the exit plane of the converging duct. अभी मैं converging diverging की बात नहीं कर रहा हूं. I'm talking only about converging duct. उसके आउटलेट पर मैक्सिमम टू मैक्सिमम यू कैन रीच टू Mach number 1. अब मैं आपको एक और चीज दिखाता हूं. What a beautiful thing. बेटा अब आएगा मजा. Now you will be enjoying. If you understand, now you will be enjoying. Now look at here, my friends. Let us suppose here on this axis I am taking mass flow rate. Let me say here on this axis, ध्यान से देखना बेटा. Let us suppose I am taking, देखना ध्यान से, PV by P naught. Anyone in the class बेटा, what is PV? Anyone in the class, what is PV बेटा? Anyone in the class? Naveen, what is Mach number? If you don't know, you go to my initial classes बेटा. If you don't know what is Mach number, you go to my initial classes beta. Okay, chalo. What is the PV here beta? Anyone in the class? What is PV here? Confirm karo mujhe. Can you tell me what is PV here beta? Can you tell me what is PV here? Can you tell me what is PV here beta? Back pressure, yes. What is P naught here? 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 Anyone in the class? What is P naught here beta? What is P naught here? What is P naught here? P naught. Can you tell me what is P naught here? P naught is the stagnation pressure. Now look at here. Try to understand. Try to understand. Any intelligent student of the class can tell me. देखना बेटा. If here PV by P naught is 1, what is the meaning of this beta? If here PV by P naught is 1, what is the meaning of this? अगर PV by P naught 1 है, तो what is the meaning of this? PV is equal to P naught. When can I say PV will be equal to P naught beta? When can I say PV will be equal to P naught? When can I say PV will be equal to P naught? Anyone in the class beta? When can I say PV will be equal to P naught? कब मैं बोल सकता हूं? Anyone in the class? When there is no mass flow rate. Excellent, excellent. When the valve is completely closed. When the valve is completely closed, right? When the valve is completely closed. Now, look at here. Let us suppose. Yes, very good beta. Let us suppose I am opening the valve a little bit. If I am opening the valve a little bit, what will happen to the mass flow rate? Mass flow rate will increase. देखो बेटा, when PV by P naught is 1, when PV by P naught is 1, there is no doubt the mass flow rate is 0. So I am here. Now what will happen? The flow will start. Velocity will start increasing. If velocity will start increasing, mass flow rate will start increasing. Mass flow rate will start increasing. So let us suppose when I opened a little bit, I reached here. Now, if I further open the valve, what will happen? Mass flow rate, velocity will further increase. Velocity will further increase. Mass flow rate will further increase. So, if I am opening the valve a little bit, PV is decreasing now. I hope you are able to understand beta. PV is decreasing. PV is decreasing. PV is decreasing. PV by P naught is decreasing. Mass flow rate is further increasing. Mass flow rate is further increasing. Now let us suppose in the next case I am opening the valve in such a way that the velocity of the fluid flow becomes equal to the speed of sound. Now what will happen beta? Next stage, mass flow rate will further increase. एक एक चीज आपको करके दिखा रहा हूं बेटा. Mass flow rate will further increase. And here at this point your Mach number will become equal to 1. Now if I am further opening the valve, what will happen? PV will further decrease. If PV will further decrease, PV by P naught will further decrease. But what will happen to the velocity of the fluid flow? It will not increase. If it will not increase, mass flow rate will not increase. That means now from here it will be like this. From here it will be like this. Oh my god, that means this is your maximum. Beta clear हो रहा है, crystal clear. I am going very slow in this concept. बहुत लोगों को बहुत doubt रहता है. That's why I want you to be crystal clear in this. I hope everyone is crystal clear with this. बोलो रे बाबा. Are you clear till here? Excellent, excellent. Beautiful students. Beautiful students. Bolo re baba, are you clear? Dekho, dekho, dekho. This is the case when the valve is completely closed. Completely closed. When the valve is completely closed. When the valve is completely closed, mass flow rate is 0. I opened the valve a little bit. PV decreased, velocity increased, mass flow rate increased. I further opened the valve. PV further decreased, mass flow rate further increased. But now let us suppose I am opening the valve in such a way that now I am having the sonic velocity of the fluid flow. That means the velocity of the fluid flow is equal to speed of the sound. Now my Mach number is 1. If I further open the valve, now the things are not going to change. आपको याद आ रहा है? This I have represented by naught. This I have represented by 1, 2, 3, 4. देखिए ध्यान से. Are you clear till here? बोलो रे बाबा, बोलो रे. What a beautiful concept. Now listen carefully. Such a situation when we are having the maximum mass flow rate through the converging nozzle, we are calling it choking in nozzle. We are calling it choking in nozzle, and such flow is known as choked flow, and such flow is known as choked flow. Are you clear till here? बोलो रे बाबा, बोलो रे बाबा. अरे सुनील, वो हो सकता है ना, लेट अस सपोज आई एम कनेक्टिंग सम वैक्यूम पंप एंड ऑल. उस पे मत जाओ. You tell me, are you clear till here? Even though I have decreased to very lesser value of PV, you see the mass flow rate will remain maximum. It will not increase further. बोलिए बेटा. तो आपको इतना समझ में आ गया होगा. If you see in this zone, your PE is equal to PV. Here the Mach number is 1. Here also your PE is equal to PV. But if you see here you are having different situation. बोलो रे बाबा, are you clear till here? Now any intelligent student of the class, देखो यहां Mach number 1 हो गया था. I am writing here you are having Mach number 1. बेटा बहुत ही बेहतरीन कॉन्सेप्ट बता रहा हूं. Here you got Mach number is equal to 1. बेटा if Mach number is equal to 1, what is the meaning of that? PV is equal to what? Back pressure is equal to what? Back pressure is equal to sonic pressure. Back pressure is equal to what? Sonic pressure. Back pressure is equal to what? Sonic pressure. You can say sonic pressure or you can say critical pressure. There are two names. Back pressure will be becoming equal to sonic pressure or critical pressure. Now any intelligent student of the class, I am asking you one question. मैं आपको एक क्वेश्चन पूछता हूं, पता नहीं कितने लोग आंसर दे पाएंगे. Can you tell me what will be this value of PV by P naught? यहां पर PV by P naught कितना होगा बेटा? What will be the value of PV by P naught here? What will be the value of PV by P naught here? बोलो, what will be the value? अरे I have given you the formula ना बेटा. What is the formula I have given you? If you remember, P naught by P star is equal to what? Gamma plus 1 by 2 whole power gamma upon gamma minus 1. So what will be P star by P naught? P star by P naught will be how much? 2 by gamma plus 1 power gamma upon gamma minus 1. For gamma is equal to 1.4. For gamma is equal to 1.4. For gamma is equal to 1.4. What will be the value of P star by P naught, beta? What will be the value of P star by P naught? If you solve it, 2 by 1.4 plus 1, 2.4, 1.4 divided by 0.4. So how much you are getting? Tell me the answer. It should be less than 1. 0.5282. This can be your gate question. This can be your gate question. You know what will be the gate question? What will be the ratio of back pressure? What will be the ratio of back pressure to the stagnation pressure when the flow will become choked flow? What will be when the flow becomes choked flow? What will be the ratio of back pressure to the stagnation pressure for the choked flow through the converging duct? What will be your answer? Excellent, Nitika. Very good, very good, very good, very good. Yes, सुनील वही तो बोल रहा हूं मैं. Excellent, excellent. Yes, if we are having vacuum pump at the outlet, we can maintain 0 also. No problem. सुनील वही बोल रहा हूं. सुनील खान बोलो रे बाबा, बोलो रे बाबा. Are you clear till here? What a concept, what a concept, what a concept. Clear करो रे बाबा. Are you clear till here? Are you clear till here? यहां तक सब लोग clear हैं. I hope everyone is clear till here. What is happening here? Here the exit pressure of the converging duct is equal to back pressure is equal to stagnation pressure. Here what is happening? This is less than stagnation pressure. Here it is equal to P star. At this point, confirm कर दो रे बाबा, confirm कर दो रे बाबा, confirm कर दीजिए. चलो मजा आया? ये बताइए, मजा आया बेटा चीजों को समझने में? अभी आपको क्लैरिटी देखो. यू मस्ट हैव सीन दिस डायग्राम अर्लियर आल्सो, लेकिन आपको मतलब समझ में नहीं आएगा. आज मैंने आपको पूरे मतलब क्लियर कर दिए बेटा. आज मैंने आपको पूरे मतलब क्लियर कर दिए. This line is representing for 0 opening of the valve, first opening of the valve, second opening of the valve, third opening of the valve, and then fourth opening of the valve. कंफर्म कर दो बेटा. Fourth opening the valve. Similarly here, 0 opening of the valve, first opening of the valve, second opening of the valve, third opening of the valve, and the fourth opening the valve I am representing by red ink. Okay, clear. मजा. हाँ बेटा वही लिखा है नितिका. आई हैव रिटन द सेम. पीवी इज लेस देन पी. करेक्ट, पीवी इज लेस देन पी. चलो बेटा, फिर वी विल स्टॉप टुडेज क्लास हियर ओनली. मैं आपको कोई ज्यादा तगड़े डिटेल में नहीं ले आना चाहता, लेकिन अभी आपको इतना तो समझ में आ गया होगा कि कैसे चीजें आ रही हैं. आज आप इस कॉन्सेप्ट को समझिए. नेक्स्ट कॉन्सेप्ट विल बी स्टार्टिंग इन द नेक्स्ट क्लास. मैं आज चाहता हूं कि आप इसको पूरा एब्जॉर्ब कर लो. यू कंप्लीटली एब्जॉर्ब दिस पार्ट. बेटा, है ना? यू कंप्लीटली एब्जॉर्ब दिस पार्ट. बेटा मजा आया हो तो एक काम कर देना आप लोग. इफ यू एंजॉय टुडेज क्लास, माय हम्बल रिक्वेस्ट, काइंडली शेयर दिस पर्टिकुलर क्लास विद एवरीवन. ये जो कंप्रेसिबल फ्लो की क्लासेस चल रही हैं, दिस इज द न्यू टॉपिक इन गेट सिलेबस एंड सो मेनी स्टूडेंट्स आर स्ट्रगलिंग टू फाइंड द right content for the compressible flow. So I request you kindly share the link of compressible flow with all your friends so that they can take the advantage of this. है ना? नोटिफिकेशन नहीं आया बेटा. आपको तो पता है ना मेरी क्लासेस 6 o'clock होती हैं. मेरी क्लासेस 6 o'clock होती हैं. यस. ठीक है, देखो बेटा, अब थोड़ा सा एक फिजिकल फील ले लो। द फ्लो वेलोसिटी कैन नेवर बी ग्रेटर देन सोनिक स्पीड थ्रू द एग्जिट ऑफ कन्वर्जिंग नोजल or through the throat of converging diverging nozzle, because once the sonic speed is attained, a pressure wave at this speed can no longer move upstream against the flow to send the signal of any changes downstream that may cause a further increase of flow in the nozzle. आप लोग सोच रहे होंगे ना, आप लोग सोच रहे होंगे अरे इसके बाद फ्लो इंक्रीज क्यों नहीं हो रहा है। यू मस्ट बी थिंकिंग ना, व्हेन द वेलोसिटी ऑफ द फ्लूइड फ्लो बिकम्स इक्वल टू द स्पीड ऑफ द साउंड, वाई ऑन डिक्रीजिंग पीवी, अगर मैं पीवी डिक्रीज कर रहा हूं, इफ आई एम डिक्रीजिंग द पीवी, वाई दिस वेलोसिटी इज नॉट इंक्रीजिंग फर्दर। द रीजन इज गिवन हेयर, द फिजिकल रीजन इज गिवन हेयर। क्या होता है बेटा, ध्यान से देखो, when once the velocity of the fluid flow becomes equal to the speed of sound, what is happening here? Now the pressure wave will not able to reach to upstream. The pressure wave at this speed can no longer move us upstream to send the signal of any change in downstream. Arey, I am decreasing the pressure here, I am decreasing the pressure here, but now already fluid flow is having the velocity of speed of the sound. Now the velocity of the fluid flow is equal to the speed of the sound. So if I am decreasing the pressure at the downstream, the moment I am decreasing the back pressure, that signal is not reaching to the upstream, that signal is not reaching to the inlet of the nozzle, that now the pressure has been decreased, now you start increasing the flow. मैं आपको समझाता हूं क्या बोल रहा हूं बेटा, ध्यान से सुनना. What I'm trying to tell you, listen carefully. Let us have the crystal clear concept. Look at here, my friends. Now once the fluid is having the velocity of speed of sound, एक बार यहां पर let us suppose here the velocity of the fluid flow becomes equal to the speed of the sound. Now if I'm decreasing the pressure here, now if I'm decreasing the back pressure here, the pressure wave will not able to travel to this upstream part. प्रेशर वेव बेटा ये अपस्ट्रीम तक पहुंच ही नहीं पाएगी. प्रेशर वेव विल नॉट एबल टू रीच टू दिस अपस्ट्रीम पार्ट, यहां तक पहुंच ही नहीं पाएगी. दैट सिग्नल विल नॉट एबल टू रीच टू द इनलेट, ये प्रेशर वेव यहां तक नहीं आएगी. एंड द सिग्नल विल नॉट रीच दैट प्रेशर हैज बीन डिक्रीज्ड, यू स्टार्ट इंक्रीजिंग द फ्लो. लुक एट हियर, ट्राई टू अंडरस्टैंड. Once the sonic speed is attained, a pressure wave at this speed can no longer move upstream. This pressure wave can no longer move upstream against the flow to send the signal of any change, to send the signal of any changes downstream that may cause a further increase of flow into the nozzle. That doesn't matter बेटा. सुरेश उसका आपको कोई जरूरत नहीं है ना, ठीक है ना बिटू, नो प्रॉब्लम. कीप शेयरिंग. नाउ लुक एट हियर माय फ्रेंड्स, लुक एट हियर. इफ यू वांट टू डाउनलोड द नोट्स or if you want to watch my free classes, all the free classes whatever I have taken till now, either on Unacademy special classes or on YouTube in a systematic way, my friend, then you can join my telegram channel Negi 10. आप Negi 10 telegram channel सर्च कर लीजिए. You just search the telegram channel Negi 10 and you can join this telegram Negi 10. If you are not able to search the Negi 10 telegram channel, you just do one thing. In your address bar, you just type this link, and after typing the link, you just hit the enter button. You will be entering to Negi 10 telegram channel, और या फिर आप अपने उस पे भी डाल सकते हैं, है ना. Now if you want to follow me on Unacademy, my name is Devendra Singh Negi. You can follow me over here. The moment you are following me, what will happen beta? You will be able to see my all the free classes. आप मेरी सारी की सारी फ्री क्लासेस देख पाएंगे. वट एवर द फ्री क्लास आई विल बी टेकिंग इन फ्यूचर, यू विल बी गेटिंग द नोटिफिकेशन ऑफ माई फ्री क्लासेस. अदरवाइज यू कैन डू वन थिंग, यू कैन टाइप दिस इन योर एड्रेस बार. आप इसको एड्रेस बार पर टाइप कर दीजिए. and you will be able to get the link of my profile of the Unacademy. Now, those who want to download, my free classes from the YouTube, those who want to download the class notes, they can search this, they can type this tiny URL in their address bar. Just type tinyurl.com/negi10 code. You'll be getting all these Excel files, my friends, where I have arranged everything in a very systematic way. For example, chapter number 1, अगर आप देखेंगे chapter number 1, fluid and its properties, how many lectures are there? 24 lectures are there. Everything, what is the topic of each and every lecture, I have arranged properly. The class links I have arranged in this column. Class notes link I have arranged. Every class is having the class notes. You can download the class notes also. Now look at here. This is already over. Today it's already over. Tomorrow we have started MSQ, MCQ, NAT question practice series. Tomorrow Approve sir will be taking the class. You can attend his class, my friends. Now one more thing, today at 10 PM Pallab sir will be taking one special session. You can attend that special session also. And my friends, 100 days free crash course, 8 days to go, 600 hours live classes, 4 subjects every day, complete syllabus will be covered. It will be starting from 1st of October. Now these are the batches which we are running on Unacademy Plus. Beginners batch for the second year student, Explore batch for the third year student, Target Gate 2021 batch for mechanical students, 4th year or passed out students, and those who are preparing for XC batch, my friend, this is the course right now which is running. I am personally taking care of this batch. If you are having any doubt regarding to this batch, you can send me the message on Unacademy Learning app. वहां पर आप जाइए, मेरी प्रोफाइल पे जाइए, वहां पे आप मुझे मैसेज कर सकते हैं. I will be able to reply you. This is the all-star batch, my friends, which we started from 21st of September. Here in this batch, all the star educators of Unacademy mechanical team are taking the classes. I will be taking the classes. Marut sir will be taking the classes. Mudit Raj sir will be taking the classes. Gaurav Babu sir, Aprup sir, Rajiv Singh sir, Jitendra Singh Gill sir. The star educators are taking the classes in this particular batch. So if you are interested for the crash course, what will happen in this crash course? My friend, this crash course will be highly beneficial those who are looking for very good gate rank. My friend, gate 202 was not difficult. Gate 2020 was not difficult. It became difficult because students haven't practiced the various types of problems. So my friend, this is basically a practice course where you'll be getting the different varieties of problems. So if you are interested, you can join, because from tomorrow onwards, from 24th of September onwards, I will be taking the heat transfer in this batch. So you can join from tomorrow onwards. This is the batch, my friends. This is the comprehensive course on basic thermodynamics. So many students who are going to write their XC paper 2021. Those who are looking for, those who are in second year or third year, those who want to start from the basics. The good news for them is I am starting the basic thermodynamics from 26th of September. You can join 26th of October, my friends. You can join this batch, right? Now you are aware of this mechanical plus XC matlab Negi 10, right? Now my friends, what are the benefits of Unacademy Plus? You can get the daily practice problem in the class notes. You will be getting the practice sheet. You will be getting the doubt clearing session. You will be getting the doubt solving group, weekly quizzes, quiz discussions. You will be getting the revision classes, and most importantly, you will be getting my personal guidance. Now these are the benefits. If you are taking the single subscription, you will be getting the multiple papers, multiple batches, multiple educators. How to join Unacademy Plus? I will be telling you, my friends. Unacademy Plus को join करने से पहले समझ लीजिए कि आपको क्या-क्या चीजें मिलने वाली हैं Unacademy Plus पर. You will be getting the live classes, you will be getting the test series, you will be getting the structured schedule, you will be getting the unlimited practice, and if you can afford the Unacademy Iconic, you can pay little more and you can join this Unacademy Iconic. What is the benefit of this Unacademy Iconic? You will be getting the dizzy coach, you will be getting the personal coach. This personal coach will be giving you the expert guidelines. The personal coach will be giving you the study planner. This personal coach will be helping you in engineering services question answers also, mains question answer also. How to join Unacademy Plus? Download Unacademy Learning app, click on Get and ASC category, click on Get Subscription. If you are preparing for 2021 competitive exams, you can take for this 12 months. If you are preparing for 2022 competitive exam, then you can take this 24-month program. After applying your own referral code Negi 10, your fee will be reduced to 22,500 for 12 months, 27,000 for 24 months. Why to use Negi 10 referral code? Because Negi 10 is not just the referral code, my friends. It's an emotion which is connecting me to you people, which is connecting Jhama Jham classes to Jhama Jham learning, which is connecting are you getting to Bolo Re Baba, Bolo Re Baba. Yes, you can pay in no cost EMI also if you are having the credit card, any bank credit card. If you are having the debit card of SDFC Bank, if you are having the Bajaj Finserv card, you can pay in monthly installments also. So my friend, the moment you are using the Negi 10 referral code, you are using my referral code, who is the top educator on Unacademy Plus, mechanical head Unacademy brands, GATE All India Rank 1 2019-20 Engineering Sciences paper, completed master from IIT-BOMBAY, teaching for GATE and ESE since 8 years. More than 50,000 students has been mentored by me, so you can be one of them. Okay, so you know mechanical plus XC matlab Negi 10. Thank you so much, my friends. So we'll stop today's class here. Okay, बिल्कुल. Thank you so much, Greece. Thank you so much. The best channel. Beta Shivam, this is new topic only, na Shivam. This is new topic only, beta. Compressible flow is the new topic only. Chalo. Thank you so much. Bye. Take care. Thank you.